Here we have the function f of x equal to the square root of 4 plus x to the third. And we want to find the area bounded by the graph, by this graph and the x-axis from 0 to 4. And we want to approximate the shaded region with 8 trapezoids. And so this is what the graph of the function looks like, and is filled with 8 trapezoids. And so we want to know what is the approximated area of the shaded region. And so we will use trapezoid's rule. And again, this is trapezoid's rule, and in this case, b will be 4, a will be 0. And so the width of each rectangle will be 4 minus 0 divided by 8, which is 0.5. So the width of the first rectangle will be 0.5. The width of the second trapezoid will be 0.5. The width of the third trapezoid will be 0.5. The reason because from here to here is 0 to 4, and we're dividing it by 8. And therefore the width or the height of each trapezoid will be 0.5. And so this is x of 0, which is 0. And then this is x of 1. This is x of 1. And so it would be x of 1 is x of 0 plus 1 delta x. X of 2 would be x of 0 plus 2 delta x. X of 3 would be 0 plus 3 delta x. X of 4 would be x of 0 plus 4 delta x, and so on. And so that's how we would figure out the x of y's. The reason we need the x of y's is to calculate all of these f of x of 0, x of 1, x of 2, x of 3, all the way x to x of n. In this case, n is 8. And so that's why we have to figure out the x of y's first. And so x of 0 will be 0, and so it'll be 0 right here. And then x of 1 is right here, and this is be x of 0 plus 1 delta x. Delta x in this case is 0.5, so it would be 0 plus 0.5, which is 0.5. And then x of 2, it'd be x of 0 plus 2 delta x, or two widths here. And so it'd be 0 plus 2 times 0.5, which is 1, and so we get 1. X of 3 would be x of 0 plus 3 delta x. And so it would be 0 plus 3 times 0.5, which is 1.5. So we get 1.5. And then x of 4 would be x of 0 plus 4 delta x. And so it would be 0 plus 4 times a half, which is 2, and so we get 2. And then so on. And so that's how we would figure out the x of y's. And so in this case, we need to go all the way up to x of 7, x of 8. And so x of 7, which is right here, it'd be x of 0 plus 7 delta x, but delta x is 0.5, and so 7 times 0.5 is 3.5. And then the last one, we remember that the interval is from 0 to 4, and therefore x of 8 should be 4. And then after we calculate the x of y's, we would go back to the formula and calculate the f of x of y's. And so we will need to calculate f of x of 0, f of x of 1, f of x of 2, all the way up to f of x of 8. And again, notice that the multiplier here is 1, or the number in front, the coefficient here is 1, the coefficient here is 2, and so it's 2 for all the terms in between. And then the multiplier is just 1 here for the first, and then 1 here for the last. And so again, this is where we approximating the shaded region with trapezoids, and so it'll be just the approximated area. And so it would be much easier and faster if we can just do the definite integral. But the problem is, for a function like this, there's no antiderivative, and therefore we cannot do the definite integral, and we have to use something like trapezoid's rule. And so now we have figured out the exabytes, and we will go to Google Spreadsheet to help us figure out the f of exabytes, and then add all these numbers together. This is Google Spreadsheet, and so first we'll input A, we'll input B, and then n, the number of rectangles, and then we'll go ahead and calculate. Remember that this is delta x, and so let's go ahead and calculate these two numbers. So for delta x, it's just b minus a, and so we would do equal parentheses, and then b is in this cell, cell B2, and then minus 8 is in cell B1, and then dividing by n, n is in cell B3, and that will give us, and so let's back up, b was 4, and so let's change this to a 4. And so that will give us a delta x of 0.5. And then notice that in the trapezoid's rule, the formula, the expression in the front is b minus a divided by 2n. And so let's go ahead and calculate the expression b minus a over 2n. And so we would do parentheses, open parenthesis, and then b is then cell, so first we need the equal, equal, and then open parenthesis, and then b is in cell B2, minus a is in cell B1, and then dividing by 2 times, and then n is in cell B3, and that will be b minus a divided by 2n. And then we have to give it the initial exabyte. This is our exabytes right here. The first one is 0. The next one is 1 plus delta x. The next one is 2 plus delta x. The next one is 3 plus delta x. And so x of 0 is 0. And then this one, we need it to be x of 0 plus delta x. Delta x is this b5 right here. And then we're going to copy, Control C on the keyboard, and then paste. And so let's back up. And so remember, this is x of 0, this is x of 1, and so for x of 2, then we need x of 0, and then plus 2 times delta x. And then this one, we need x of 0, and then plus 3 times delta x. And then the next one, we need x of 0, and then plus 4 times delta x. And then equal x of 0, and then plus delta x. And this will be 5 times delta x. and then 6, it'd be 0. And then if we want to keep that this cell right here, this cell C2 constant, then what we need to do is do the dollar sign in front of the C and the 2. And then we want the this to remain constant too, the delta, which is in cell B5. So it would be dollar sign B, dollar sign 5. And then this time we want this to be, this is x of 0, 1, 2, 3, 4, 5, 6. So this would be 6 times. And then we copy this right here. And then we need to change this to a 7. And then if we paste right here, and then change this to an 8. And so first way we could add an additional column where we would have 0, 1, 2, 3, 4, 5, 6, 7, up to 8. And then each time we would multiply, and that will make it faster. And so this is x sub I. And then next we need f of x sub I. And so f is the square root 4 plus x sub I to the third. And so to input the function, we would type in equal, and then SQRT for square root. And then we would do 4, and then plus, and then x sub I, whatever cell, the first x sub I is in cell C2, so we would put C2 right here, C2, and then hat 3 for the square root, and then close parentheses. And this will give us the square root of 4 plus x sub I to the third. So here we would type in equal, so equal S, Q, and then we want SQRT of 4 plus x sub I, which is this cell, and then hat 3, and then close parentheses. And then it will ask us to autofill, and so it will do the calculations automatically for the other x sub I's. And then if we liked it, then accept it. And then the m is the multiplier numbers. And so the first one, the multiplier be 1. The last one, the multiplier be 1. And then everything else in between will be 2. And so here we would have 1, and then 2, and then 2. And then a 1. And then next, we want the the f of x sub I multiplying by m. So this times m, or m times f of x sub I, same thing. And then it will do the calculations automatically for these cells right here. So we click accept. And then the last thing we need to do is we need to add all of these together and then multiply it by b minus a over 2n. And so first let's get the sum. So we do equal sum of these cells right here. And then close parentheses. And that will give us the sum. And then now we want the area. And the area is going to be the b minus a over 2n. And then times the sum. And so the sum of the areas of the 8 trapezoids is 16.20. And that's what we saw on the graph earlier. The sum of the 8 trapezoids is 16.20. And again, obviously, if we we can tell that this is a very good approximation of the shaded region. And then if we want better approximation, then what we do is we just increase the number of trapezoids. And the approximation of the shaded region will get better and better.